Let's look at two more examples of hypothesis testing for averages or means. So the sentence claims the average hours of sleep Butte College, that should say students, get per night is less than 7 hours. So again, that phrase less than 7 hours, the word average tells me I'm going to use mu less than 7. I put it here because it doesn't contain an equal sign. The complement of this less than would be greater than or equal to, but we know we just use equals. I've also stated early on my significance level, my alpha level. That's the where small begins less than 1. It's usually 5, but I just thought we'd mix it up. And here's another scenario where sometimes the data is just summarized for us, but I like to show you every once in a while. You may be just handed a data set. And so, again, step 1 is to take this data set. This is actually from a stat class, one of the surveys I gave. So 28 students replied how many hours of sleep they got the night before. You guys know how to put that into a list. Head back to the home screen and stat calc 1var stat of that list gives me my summary statistics. So let me jot down the important summary statistics from my screen. We know there are, my sample size is 28. The average hours of sleep, my sample mean, looks like it's 6.3, 1 decimal looks good, and my sample standard deviation, 1.6462. Okay, that's plenty. So, we'll again ask the question, do I have evidence right now to support my alternative? Yes, my sample mean is less than 7. So, let's build a case for the test. We've got means and my test statistic, T. My null is 7 hours. My sample mean came in less than that. So this is an example of a left-tailed test. And remember, because it's a t-curve, not a normal curve, there's a degrees of freedom associated with this, 1 less than my sample size. And we're at the stage where we grab our calculator and head to stat test number 2 for t-test. Remember, when you're given a data set and you run 1var stat, that data, the summary statistics, is already fed into this screen. So I just need to tell my calculator my null is 7. The next 3 things are good, and my alternative was less than. Calculate, and we've got my 2 numbers I didn't have before, my test statistic and my p-value. So my test statistic, right here, negative 2.24, and my p-value 0.0168. So again, the p-value is the area of this tail. Now, normally that's considered pretty small, but remember, I said back here my alpha level was 1%. We didn't get smaller than 1. So my decision is, since my p-value is greater than 1, fail to reject the null, which means my conclusion, we have weak or insufficient evidence to support the alternative that it was less than 7. I'll say HA. It could be true. The average is 7 hours. The null, not less than 7. All right, last example. This states the average weight gain gain of adults during the stay-at-home orders is 10 pounds. My null and alternative, this is saying the average is 10, is an equal, so mu equals 10. The complement of that would be mu not equal to 10. And I've got, I think I was going to say this was 8.2 and 1.8. So let's say a survey of 30 adults was given, asked how much weight they'd gained, and the average weight gain was just over 8 pounds with a standard deviation, 1.8. So one more time, degrees of freedom, 29. I've got my means, I've got my t, my null is 10. My sample mean comes in under that. And we shade that left tail. But one more time, anytime we use a not equal sign, this is actually a two-tailed test. And so I've got the same area on both sides. One thing that's nice to do is ask yourself, how many pounds away is 8.2 away from 10? Looks like it's about 1.8. Not. So if I were to add 1.8, it's the same as if they had gained 11.8 pounds. Let's head to my machine, test number 2. And this time I have to enter my summary statistics. The null is 10, average 8.2, standard deviation 1.8, sample size 30, not equals, calculate. So let me get that t-score first. So 5.48 negative. Well, it would be like a positive 5.48 here, but I wanted to make sure you guys saw an example of a p-value that looks like this. It looks like it's saying 6.7, but all p-values have to be less than 1. And so that doesn't make sense until I look over here and see it's saying, this is a very tiny number actually, e to the negative 6. So let me write down 6.739. That's plenty. And then take it over from here. What does that e to the negative 6 really mean? That says we're going to move this decimal 6 positions to the left. Well, 1 gets me to the other side of 6, so that would give me 0.00006739. We typically go to the 4th decimal place, so I think we're good to say my p-value is essentially 0, very tiny. If I say my alpha level is our classic 5%, then my decision, since 0.000 is less than 5, reject the null. My conclusion, we have strong evidence to support the alternative, which is the average weight gain is not 10 pounds.